we are on the last chapter, chapter 12, that's about quadratic equations. As always, we begin simply, where we are going to look at quadratic equations with perfect squares. In fact, we've already solved some of these. If I say m squared equals 49, you know that to undo the m squared, we take the square root. And anytime I use that square root symbol to solve, I have to remember it could be positive or negative, because the square of positive 7 is 49 and the square of negative 7 is 49. Similarly, we've learned, I think, in the last chapter, if I want to do 5r squared equals 45, I can first divide both sides so that I have r squared equals 9. And when I take the square root of that, I get r is equal to positive or negative 3. The big idea here is that you want to get the side of the equation with a variable to equal a perfect square. And sometimes this means we're going to have to factor first. And this only works because we're talking about quadratic equations with perfect squares. So, and then second, we're going to root both sides and solve. Okay, so let's see how that looks. First of all, we have ones that look like x plus 6 squared equals 64. Well, here's our side of the equation with a variable, and it's already a perfect square. So to get it along, I can root both sides. Square root of 64 is 8, and then the square root of x plus 6 squared is x plus 6. Now this isn't quite finished, because to get x alone now, we have to subtract 6. So that means that x is equal to negative 6 plus 8, that's the plus, and x also equals negative 6 minus 8. That makes our two solutions 2 and negative 14. And if we go back and plug those in, we will see that 2 plus 6 squared does in fact equal 64, because this is 8, and 8 squared is 64. And negative 14, plus 6 squared also equals 64, because this is negative 8 squared, and that equals 64. Sometimes, well, actually, no, I'm not ready for that. 5 times x minus 4 squared is equal to 40. So we need to get the expression with the variable as a perfect square. We need that alone. So the first thing we're going to do is divide by 5. That gives us x minus 4 squared is equal to 8. When I take the square root of that, this side has x minus 4, and this side has positive or negative 4 root 2. I hope you still remember this. It's just last chapter, but this is root 4 times root 2 equals root 8, and the square root of 4 is 2. Excuse me. That is 2 root 2. Good thing I was made to check my work because of you. And now, to get x alone, I add 4, and that means that x is equal to 4 plus or minus 2 times the square root of 2. Onward. Y squared plus 6y plus 9 is equal to 49. Well, sometimes kids say, okay, well, here's a perfect square. Should I get that alone? But that would bring 6y and 9 to the other side, and we can't make them, there's no way to make that a perfect square. So the first thing you need to do in these situations is to factor it so that it becomes a perfect square. When I take the square root now, I find out that y plus 3 is equal to positive or negative 7. When I subtract 3, I find out that y is equal to either negative 3 plus 7 or negative 3 minus 7. This one gives me 4. This one gives me negative 10. Each of these would make this equation, this original equation, true. How about this one? 2 times 3x minus 5 plus 15 equals 7. Well, in getting that this has to be squared. In getting that square alone, I subtract 15, and I get negative 8. Now, we could stop right there, but I'll keep going so you can see why. 3x plus 5 squared is equal to negative 4. And here's why. When I take the square root of negative 4 is not a real number. So there are no real solutions. Okay, so I'm going to abbreviate that. That's among the hardest that you have to do. If I say x squared minus 6x plus 9 equals 32, first thing we'll recognize is that this is a perfect square trinomial, so it's x minus 3 squared is equal to 32. When I take the square root of both sides, I automatically have to say plus or minus, and this one is x minus 3, and 32 is really 16 times 2, so that is 4 root 2, and when I add 3 to both sides, I have 3 plus or minus 4 root 2. Notice, since I can't combine these, that is my answer. If I ended up with x equals, I don't know, 10 plus or minus 3, then since these are both numbers, that's why I have to do 10 plus 3 and 10 minus 3. This would be 13, this would be 7. But I don't have to worry about that here because I have a radical. It's in simplest form.